And I'll point out the fire exits for the venue. We plan to have a full house tonight. There's still people coming in. So the fire exits are just to the right and left in the rear. There's also one in the front right down here, in case you need to use that. If you're on Twitter, our hashtag for tonight is #FutureEnergy. So if you have a mobile phone and you're using your 3G network, or you need Wi-Fi, you can just connect to the MIT guest network, MIT ID, and you'll get on the Wi-Fi and you'll be able to tweet. We encourage you to tweet. And again, you're using the Twitter hashtag for tonight. That's #FutureEnergy. So I'm Chris DeLuca, and I'm the founder of Ultralight Startups in Boston. We've been around for about 5 years, and we help companies connect with startups. We do this through online communities and pitch events, much like what you're about to see here tonight. We have 2 tracks from Ultralight Startups events. One is a high-tech internet series, and the other is a future energy track. And tonight, you're going to see the future energy track. It's energy and clean tech companies presenting to a panel of esteemed and brilliant investors, and they're going to be giving feedback and insight for the companies to take their team to the next level. Keep in mind, for a lot of companies, this is almost their first time they're actually speaking in public about this event, about their company. So it's really useful from their standpoint because they're really taking a lot of new feedback, opportunity for them to get some exposure. But also, if you're thinking about working on an internet startup in the energy sector, then you want to basically pay attention because maybe you could pitch here as well someday. Okay, so Future Energy is sponsored by Shell and the GameChanger program, and you'll hear about that in a little bit. Ultralight Startups is the largest pitch event community in Boston, New York, and Silicon Valley, and we'll tell you in a little bit about events happening in other cities. If you happen to be there, you can certainly join in. I'll also introduce to you my co-host, Graham Lawler, the founder of Ultralight Startups, based in New York City. And Graham.
Awesome. Thanks very much. Thanks, Chris.
Sure.
It's great to be here. I come up for events in Boston whenever I can. It's always great to be here for Ultralight Boston. So thanks very much.
Thanks, Graham. So before we jump into the format, I'm just going to ask for George Miller and Sam Shaner to step up. So as mentioned, this event is in partnership with the MIT Clean Energy Prize here. So these 2 gentlemen are here from the Clean Energy Prize, and they're going to tell you a little bit about CEP.
Excellent. Thank you, Chris. So the Clean Energy Prize is the nation's premier clean energy business plan competition, and we were lucky enough to host this event with Ultralight Startups. And tonight you'll see 8 excellent pitches, and 4 of those will be from student teams here at MIT working in the MIT Clean Energy Prize. These are just a fraction of the 18 teams we have this year from all over the country competing for over $300,000 in prizes in our finale event on May 6th, which I encourage you all to attend. And George here will tell you a little bit more about the prize we have for tonight.
Yeah, so apart from the $300,000 in prizes that CEP contestants are able to win in the prize, we also have $1,000 tonight for the top Clean Energy Prize team, which is being awarded by GE. GE Ventures is a new sponsor of ours that we're really happy to be working with, and a great supporter with mentors and judges. But they have happily contributed $1,000 to the top Clean Energy Prize team, which is going to be determined by you all. So definitely get your votes in at the end of this, and we're looking forward to some good pitches. So thank you, Graham. Thank you, Chris.
Thanks, George. Thanks, Sam.
Okay. So Graham, would you like to tell everyone about the format?
Absolutely. Okay, so this is the format of the event that you'll see tonight. There's going to be 8 startup pitches that will come up one by one. We'll talk a little bit about the pitch format itself. You will be deciding on the winners of the contest. So you're going to be voting at the end of all the 8 pitches on which ones you thought were the best. And also, we're going to be voting on the panel. So we'll talk about that a little bit, which panelist you thought gave the best advice. After the pitches and after the contest and the awards, we will all go over to Mead Hall, which is a very short 5-minute walk from here, where we have the bar upstairs reserved for networking. I should tell you about how we got to the 8 companies that we're going to see here today. So we opened applications for this event about 2 months ago, And we worked with a number of organizations, both on campus here at MIT and in the Boston, Cambridge area, and in New England, across the Northeast. We got 107 companies applying to present here. We filtered those down. We only wanted to look at the early stage companies from amongst the applicants. We also launched a crowd voting portal, which maybe some of you participated in, where companies could create a profile and get their friends to vote for them. And the two companies that got the most votes on the crowd voting site got automatic spots to pitch here. And then we had 6 companies from our selection committee, including a total of 4 from MIT Clean Energy Prize, as Sam and George were mentioning. We wanted to get a cross-section of technologies, so a number of different renewable energy sectors, software, oil and gas, so hopefully we have a little bit of something for everyone. And all of the 8 teams that you're going to see here were coached by our professional pitch coach, Mac Lipscomb. So, Chris, you want to talk about the panel?
Sure. So, as mentioned, we have a great panel here lined up for you tonight. I'll just introduce them real quickly. And what we ask of the panel, as they introduce themselves, is to mention a little bit about their firm, a recent investment that they made, and why they're so excited about it. So, we'll start right here down the line with Nikhil. So, Nikhil Garg of Black Coral Capital. Nikhil, tell us about your firm, your most recent investment, and why you're so excited.
Sure. Yeah, Nikhil Garg with Black Coral Capital. Been an energy and environmental investor for about 6 years now, originally in carbon markets and more recently with Black Coral Capital, where we invest in early stage venture, growth equity, and project stage investments across a wide range of clean tech companies. Our most recent investment was into a community solar project developer based out of Boulder, Colorado, called Clean Energy Collective. Very excited about them because they are reinventing how the 85% of the consumer market that can't do rooftop solar, how they can access and benefit from solar power.
Thank you, Nikhil. Okay, and the next panelist is Gail Greenwald of Clean Energy Venture Group. Gail, tell us about your group and your most recent investment and why you're so excited.
Yeah, hi, I'm Gail. I'm in Clean Energy Venture Group. We are a angel C-level investment group here in the Boston area, very well established in the clean tech area, and I think the best reputed of the angel groups who invest in this area. I've been an angel for about 3 years now, and I've got 14 investments across a number of areas, most of which are in clean tech. I'll be true to the assignment here and talk about the most recent. I'm excited about all of them, actually, but the most recent is a company called Powerhouse Dynamics that does energy management systems for residential and small commercial applications. I'm pretty excited about the traction that they're getting in the quick food service market.
Thank you, Gail. The next down the line is Willem Rensink of Shell's GameChanger program. Willem, could you tell us about the GameChanger and your most recent investment?
So my name is Willem Rensink in Shell GameChanger. What Shell GameChanger does is incubate novel, radical ideas in an angel-way fashion. We do collaborative research and then help companies, established companies or universities or individuals to help prove their idea. And then hopefully, if there's enough strategic fit with Shell and any of the Shell businesses, that results in a longer-term relationship. So we have both a scouting function and looking at more radical solutions versus the traditional energy space. We do have an interest in future energy as well as support the traditional oil and gas and chemicals businesses of Shell. And a recent investment that we made, or I made, I'm sponsor of, is in a novel platform from gas to liquids conversion. So gas to liquids is very important for Shell, producing more and more gas. Current natural gas price is very attractive. So if you can find novel, scalable, especially scalable low-scale technologies, very exciting for us.
That's great, Willem. And finally, we have Bilal Zuberi from General Catalyst Partners. Bilal, tell us about your firm, your most recent investment, and why you're so excited.
Sure. So I'm an investor with General Catalyst Partners, a Boston and Palo Alto-based venture capital and private equity firm, managing about $2.5 billion or so. We've invested to date about 12 or so companies in the clean energy space, or advanced energy as we now seem to call it. The most recent investment would be Gridco, which is making digital transformers for the grid. So all these hunky metal devices that you see hanging on poles or sitting in green boxes outside your homes or offices, they're kind of dumb devices, about 50-year-old, 70-year-old technology. The idea is to put digital controllers on it so that they not only have control functionality, but also two-way communications. So making the grid more controllable and manageable.
Thank you, Bilal. If I could just ask all the panelists to move their mics slightly closer to them so that the audience can hear you. And also for the folks that are just starting to come in, make your way down. There's plenty of seats right in the middle here, and there's a few seats in the middle and the back. So there's a seat for everyone. There's plenty of room. Okay, so next, Graham, tell us about the startup pitch format.
Okay, so each company is going to have 3 minutes to present their idea. They're going to have 2 PowerPoint slides, which we will click through. The focus of the presentation should be on the technology and the differentiator between the technology being presented and whatever else is out there in the marketplace today. So really focusing on the technology and the differentiators around that. Also touching on the business model. So then we'll have 3 minutes of Q&A with the panel. So the panelists will be able to jump in after the 3-minute mark and ask questions of the companies to clarify. And then after that, we got 3 minutes of feedback from the panel, and we asked for this in a particular way, actionable advice. So we're asking the panel, if you were the entrepreneur, what's the first thing you would do tomorrow morning? So try and make it actionable and constructive. At the end of all of the pitches, as I said, all of you will be getting an email from me at 8 p.m. tonight, at least everybody that registered, and that's going to have a survey. So be on the lookout for that, and you click on the link, and then you fill in your votes. The prizes for the contest, let's see, we've got a number of organizations here in the Boston and New England area that have generously offered to give prizes to the startups that win this. So Cleantech Open Northeast is offering a free application. Interview at Surge Accelerator, which is a cleantech accelerator in Houston. Greentown Labs, Pass, Mintz Levin Legal Services, Work Bar passes. Work Bar is a co-working space here in Boston. Amazon Web Services credits, and an Action Pass. And then the big prize really is for the panel. Whoever gave the best actionable advice, as per your voting, wins our eternal gratitude.
That's great. So, and we'd just like to say thank you to a few of the organizations, basically many people that helped getting the word out, making this all possible, and really pulling the ecosystem in Massachusetts and New England together here tonight. So I'm just going to run down a short list of people to thank here tonight. So first of all, thanks to, and I'll ask you to hold your applause until the end of this long list. But first of all, thanks to the Shell GameChanger program and Willem Rensink for being platinum sponsor of tonight's event. Ali Adler of Cleantech Open, Ken Herb of New England Clean Energy Foundation, Sally Griffith of Massachusetts Clean Energy Council, Emily Reichart of Greentown Labs, Joan Popolo of Action, Nick Davis Agrion, Pierre Dorsaz of Swiss Next, David Zhao of UPower House, Joseline Main of Boston Tweet Up, Sarah Still Rogers, Eventbrite Boston, Walter Frick of Boston Erica Reef of Mass Challenge, Jeff McCauley, Fraunhofer USA, Bobby Carlton, Mass Innovation Nights, Abby Barrow, Mass Tech Transfer Office. All the university energy clubs, BU, BC, Tufts, Northeastern. Most of all, thank you to MIT for all of the support and hosting us here tonight. Really happy to partner with you guys. And obviously, thank you to our panel for being here and taking their time out to give their gracious feedback, as well as all the companies in the audience. A big round of applause for all of you for being here tonight. Thank you so much. Without further ado, Graham, would you like to introduce the first pitch?
Yeah, that sounds good, Chris. So the first pitch is going to be Ahmed Magdy of RE Technologies. And you're going to stand over at that microphone. And Chris is going to time your 3 minutes.
That's right.
Very closely.
I start.
So go ahead when you're ready.
Right now?
Yep.
I'm Ahmed Magdy. I'm the founder of RE Technologies here in Massachusetts. We develop a new organic solar cell architecture that basically aims to eliminate the structural inefficiencies in typical devices that is responsible for at least 35% of the loss of the incoming energy. Also, the device eliminates a lot of the unneeded and expensive components of the typical devices in organic photovoltaics used now. Our core technology are the architecture itself and the processing technique. We will be able to print organic solar cells on any surface, from wallpaper to thin plastic that you can fold or roll. This new device with its production technique are gonna increase the efficiency of the solar cells and reduce the production cost. We will be able to produce solar cells in a fashion similar to newspaper, basically as fast and as easy as producing newspaper. We'll be able to reach grid parity when we reach like 10% efficiency, panel efficiency, and we will be able to actually compete with fossil fuels when we reach 15% efficiency and we reach 4 cents per kilowatt, almost 4 cents per kilowatt hour. Our technology is based on a new way of selling, like a new selling model. We upgrade our cells every 4 years instead of having a solar cell that will live for 20 years with an ever decreasing efficiency. We upgrade them with a recycled panel every 4 years and upgraded efficiency. Currently, we are raising seed funding, and we are expecting a POC, a proof of concept, within 3 months. After that, we're gonna raise our first real funding to go through the prototype development that we expect in 1 year. We should reach 15% panel efficiency within 2 years by 2015. And then we're going to start launching our beta test when we reach an efficiency of 10%. And then we initially target market segments that have low competition because of the requirements of the application itself, like low weight and flexibility and high efficiency. But our main target market is the building owners, and then the utility scale electricity market that will be like $89 billion by 2017.
10 seconds.
I'm done.
And time. Okay. So moving swiftly into the question and answer section. So in any order, would any panelists like to jump in? What question do you have for Ahmed?
So I can start. So I didn't quite understand where you are in the process right now. What efficiency do you have? Because I have a hard time believing that a thin film process of this sort, even if it doubles the efficiency of the cells with your nanostructure, can reach 4 cents a kilowatt hour.
Okay, first we eliminate the main cost of organic solar cells, which is the substrate. We can print it on anything. You can print it on paper, you can print it on flexible plastics, you can print it on the thing that you're going to use the solar cell on. So this is to start with. We eliminate the costs of the materials, and we eliminate a lot of costs that are associated with the production itself, because we're inkjet printing. It's a very low energy production process. As well, we have like these materials are extremely cheap. So we have eliminated the main bulk of the price, and then we use a model of selling these products. Instead of having a solar cell that would live for 20 years, we actually have a panel that has like a planned obsolescence of 4 years only. After which we replace this panel with a recycled panel, because these materials are easily recyclable. You can like dissolve them with like a lot of organic solvents. So this is the model that will be able to bring us actually to this price.
Ahmed, nice job. Very interesting technology. I guess the advice I would give you for first thing tomorrow morning, if you haven't done it already, is to protect your IP. And I assume that you have done some of that, but it would be good. You didn't mention it,
yes,
so if you have.
Yeah, it's patent pending. It's
okay.
out there.
Yeah.
So this is the question and answer section. So this is the time to kind of dig into the details, and then we'll move into.
Supposed to be talking
and
about
we'll move into.
Just ask questions now.
Just ask questions. Go for it.
You mentioned that on your next step is you want to reach proof of concept, but you still claim all your cost claims and recyclability claims.
Yes.
So what is it you have demonstrated so far that you can make those claims?
I have demonstrated like calculations and simulations for most of the parts of the device itself, and then the rest of the device is like theoretically proven and approved by many professors that are like, some of them are advising me technically right now. But in terms of physical proof, I'm working on that. Like I'm gonna get a preliminary proof within a week or so, but it's gonna be using lithography, not inkjet printing. So it's not like a complete proof of concept, but the proof of concept that I'm talking here about is like a complete proof of concept with an inkjet printer and all the data in the world.
Do you know what the best-in-class organic photovoltaic efficiencies are today, given that hundreds of millions of dollars have been invested in that space, if not billions?
Yes.
What is that number?
Heliotech and Konarka has reached 10%, and they went bankrupt like 6 months ago. But I have what I have. Like this, like I'm sorry, but it's.
Don't be sorry.
Ahmed, a quick question for you. You mentioned looking to compete versus grid power and the ability to reach grid parity. I mean, you have cells that are modules that are being sold today for between 50 and 60 cents a watt. So, I mean, that pricing is already there. I would be concerned about your ability to differentiate there. Why are you looking at that market versus other potentially higher value applications, wearables, BIPV, things like that?
This is the biggest market, of course. The one with all these competitions is the biggest market. We're gonna start with market segments that actually require a lot of different set of qualities, like being very flexible, lightweight, thin, and high efficiency. This is a market with small competition, like for electric buses and electric cars, for like mobile device applications, off-grid exploration, or military applications. All that is this. We're gonna start with this to test our product and then gain some credibility, like generate revenue as soon as possible. That we can do as like the minute we reach 9% efficiency or so. But by 2015, our target is to reach the 15%, and then if we can get the other slide, but 15% is gonna be a little bit below fossil fuel. Like this is the gas. This is the best production, like levelized cost production. This is like 6.2 cents or something like that. We're gonna reach the 4 cents, and I mean, like, we can talk about how I did all the prices.
Okay, so we're going to move into the feedback section right now. So let's start with you, Gail. Would you like to think of yourself as, you're in Ahmed's shoes. What would you do if you were to wake up tomorrow morning and, revolutionize this company?
Well, since you've protected your IP, I guess given all the concern you heard about the competitiveness of this market and the billions of dollars that have been already invested, I would focus in on a high-value niche market and try to find an advisor who has some experience in that industry to work with you to try to get an in somewhere.
Feedback, Nikhil.
Somewhat similar to Gail's. I mean, I would say that if you were to pitch this with the grid scale electric market being your ultimate target market, I think that would make for a very challenging funding and general support sort of scenario. I would think about looking at alternative markets and really getting into some more detail in terms of what the economic value proposition there might be with your technology.
And Willem, feedback?
Yeah, I think you pitch a few benefits of the technology, like inkjet printing or recyclability. And I don't think people like to hear that your product only lasts for 4 years and it's easy to dissolve, whereas, I want to use it as long as I can. So I think if you look at niche applications, I think there might be sort of military applications, especially in the flexible, lightweight printing that allow these higher costs, and also where you might get a little bit more grant money, because I think it's difficult without a tangible prototype to actually convince people you got something that's real enough. And then all the concept of inkjet printing might be sort of elegant next to it, but in reality, people will look at the panel itself and what it can do for you.
And takeaway advice, Bilal.
So I think you said if I was the entrepreneur and I woke up tomorrow morning, the first thing I do is run to somebody who's a CEO of a failed solar company and try to understand the detailed LCOE analysis that you did and all the parameters that go into it. Because I'm pretty sure you're talking about 50 cents, the number that you gave, not at the module level, because that's nowhere near where you need to be. You need to be at like 20 cents or something. As you go down in efficiency, the low numbers you're talking about, the balance of system costs actually go up. You know, a lot of other crap that comes with solar actually goes up in cost. So I would really convince myself that the numbers I'm talking about are right, and then divide that by 2, because you will probably need to be in the market before you'll actually get to your eventual goal, and see if it still makes sense. And if yes, you should definitely do it.
Okay, thanks.
Excellent feedback. Round of applause. Great job.
It was wonderful advice, too. Very, very concrete, very actionable. Yeah. So we are going to go on to our next panelist, Chen of PolymerGreen. Go ahead whenever you're ready.
Can I put this number?
If you want, you can just rip the mic right off of, take it right out.
Yeah, just make sure you're speaking directly into it.
And folks in the back,
okay?
feel free to make your way down.
Hello?
There's still empty seats here in the front.
There's great seats right in the second row if you want.
Maybe not.
Hello.
Go ahead.
Hi everyone, I'm Michael Chen from MIT startup PolymerGreen. Do you know that 30 million, the US generates 30 million tons of plastic, sorry, can I restart? Because I thought there will be some sound.
Go ahead. Just continue.
Can I do now use it?
Go ahead.
And hi everyone, I'm Michael Chen from MIT startup PolymerGreen. Do you know that US generates 30 million tons of waste plastic each year? Believe it or not, 93% of them will go to landfill. We PolymerGreen convert waste plastic into oil.
Speak into the microphone. The video won't capture you unless you're speaking into the microphone.
Okay, sorry, I don't know. Okay, essentially we break long carbon chains into pieces. How does it work? Here is a diagram of our technology. After a simple treatment of the waste plastic, all of them are sent to a reactor. Different from other technologies, we do not need to vacuum our reactor. Instead of that, the catalytic reactions are happening at a low-cost anaerobic environment. And our proprietary catalyst enables the reactions with low temperature and fast reactions. After the fuel refining process, we will get fuel with a conversion rate of 80%, including the 17% of gasoline, 17% of fuel oils, and 46 diesel. In addition, optimized system integration requires only minimal external energy for operation. We are in the process of applying 3 patents. We have run our pilot plant for more than 1 year with a capacity of 20 tons of waste plastic per day. Comparing with our primary competitor, Agira, we only need $2 million for our capital X. And we can produce oil at $30 per barrel versus $40. We can break even twice as fast. Right now, we are focusing on establishing long-term partnership with the suppliers and customers. We will construct, operate, and own our commercial plants and co-locate with suppliers. We are looking for $2.5 million for our first commercial plant. Our technology is backed by a strong team with business and engineering team from MIT, Stanford, and Duke. Choose PolymerGreen, choose green future. Thank you.
Perfect timing.
Thank you very much.
Okay, so moving right into the question. So in any order, who would like to jump in and ask a question? Yes, Willem.
So the 20 tons per day, what does that translate to in amount of product?
The products?
Yeah.
Okay. Here, the data, 17% and 46% of diesel are from the experiment. We have the lab, right? But
So you're
in the real
converting
pilot,
90% of the material to
yes,
useful
in
product?
the real pilot plant, we got 10 tons of the oil. It really depends on the source of the plastic. You know, if you have impurity, more impurities, okay, you will not get that much products.
And what do you do with the waste? Is there any toxic waste in there that you're producing?
The waste, we are focusing. We will establish long-term partnership with suppliers, including, for example, recyclers. For example, when they recycle some metals from the car, they will not need the plastic. So we will collect the plastic. It's free actually in the U.S.
Next question, Nikhil.
Yeah. Can you, sorry, lost my train of thought here. Yeah, can you talk a little bit more about the process, and is it a batch process? Is it continuous? What kind of uptime and reliability have you demonstrated around it?
It is not continuous, but because the reactor, we need to take out of the residue. So it is continuous, but the efficiency of this reactor is good enough.
Building on that, you said you had a proprietary catalyst. What's the nature of that? And have you looked at fouling and survival of the catalyst over multiple uses? Are you recharging every batch, or?
Oh, you mean catalyst, right? We just throw it away because it's very cheap. The reason why we cost is very low is because we use the low-cost catalyst. For example, Agira have to reuse their catalyst because their catalyst is very high, is very expensive.
Question, Bilal.
Question related to the reactor itself. You didn't talk about what kind of reactors. Do you have to, assuming you're not building an entire, you might need to build the first plants to show that the technology works, but you won't eventually build all the plants. Is there major CapEx at the refinery end for doing this? Or can they use existing reactors and switch out the catalyst and use your product instead?
You mean the capital expense?
Yeah.
Okay, the capital expense is, as I said in the second slide, okay. In the second slide is less than $2 million, but the Agira need $11 million.
But a lot of recycling plants, when Agira plants, are probably already paid for a large extent. So this would be new capital deployed. How do you think about that? Is that just, new plant construction?
New plant.
Okay,
Yes,
so it has to
plant
be a new plant.
Yes,
Okay.
$2 million is enough.
Okay.
Michael, just a quick question about your reactors. At the pilot facility, are those at the ultimate commercial scale, or do you have further scale up of the reactor vessel that's required as well?
You mean scalable? If it is,
Does it require scale up for your intended commercial?
this system is scalable, so it depends on the suppliers. If we have a good supplier chain, so we can scale up our system.
Is your output distribution, the fractions that you get, same as what other Agira, for example, as a competitor is getting?
Output are different.
Are they producing more value-add products than you?
Actually, we use some distillation to get some final products. It's very simple. So we get diesel, fuel oil, and gasoline. But Agira gets the kind of crude oil, some number oil mixture.
Okay, we're going to move right into the feedback session. So, Nikhil, what would you like to give as a piece of advice to send Michael on his way?
Yeah, I think the biggest advice that I could give as a prospective investor, the more detailed data you could provide about the performance of the pilot facility and how that's operated over the last year would be useful to really assess the potential of the technology. I know you have a little bit in your presentation, but a lot more potential detail. And I'd also add to that, you might want to look at a broader competitive universe beyond Agilex. They certainly are a leader in the field, but there's others doing fairly interesting things as well that also look to leapfrog Agilex as well. So that would be some of your competition over time.
Okay. Great feedback. Bilal, feedback.
Sure. So if you look at the value chain that you have shown here, right? So you have these waste managements on one side, which are your sources of the plastics, right? And they have almost between the few large companies a lot of monopoly on that. So you're quite dependent on them. And on the other side, you have refineries, and you're not going to turn into a big refinery, so you're a little bit dependent on them. So you are stuck in the value chain where there's a lot of power resting on both sides of it, so you can get squeezed on your margins a lot in the middle. So I would really urge you to think a little bit about, not building a plant type scenario, because that's what you have to do to show that this thing works. But what is the right partnership arrangement? Who is your real partner? Is it a catalyst provider? Is it a, Johnson Matthey or BSF or somebody like that that can provide not just the catalyst, but also the services associated with operating that catalyst? So it can be a route to market that's different than the $2 million per plant that you've projected.
Feedback, Gail?
Yeah, Michael, nice job. Interesting technology. You say in here that not all plastic types are recyclable, and that's true, and it's true that a lot of plastic ends up in landfills, but most plastic types are, more and more are recyclable these days. Yes. So I think it would be important for you to demonstrate to a prospective clean tech investor that your carbon footprint, your energy efficiency around a process like that justify this kind of process, because frankly, I'm not convinced.
And feedback, Willem.
Yeah, so I assume that you use commingled plastics, and I think that's a real challenge in recycling. So even if you can recycle plastic, then if it's not the same type of plastic, so the commingling typically is the biggest challenge. I would see the problem is if you make a little bit of everything, do you have a real product out of a plant, or do you have enough to sort of support something? So I'd really look in your catalyst and say, can you push it to a certain direction? And then fuels are a very low value product, even if it comes from a plastic. So if you can go for a chemical and make a sort of a recyclable or depolymerize it to the base unit of the plastic, or get a chemical and a better defined stream out of it, I think you have a better value proposition than, say, go for diesel, because blending in sort of non-spec diesel or get it fuel grade is actually extremely challenging, especially if you make a little bit of it. So I know you need that scalable business model, because there's just not that big of a pile of plastic. But so tinkering around with what skill works with what product, I think will really help your business case.
Excellent feedback. Round of applause for Michael Chen. Great job. PolymerGreen.
Thanks, Michael. So next up we have Fraser Seymour of Ionova Technologies. And on deck we have Ruaridh Macdonald of Open Water Power.
I just ask that you hold your applause until the end of the feedback.
And once again, there's plenty of seats down in the front. Go ahead, Fraser.
Okay, thanks for the introduction. Actually, it's Fraser Seymour from Ionova Technologies, and here to speak. Can you hear this all right? Does that work all right? Here to talk a little bit about our zinc-ion pseudocapacitor that we've been working on, which I think it's fading a little bit. But anyway, so the zinc-ion pseudocapacitor is something like an ultracapacitor or supercapacitor. Supercapacitors basically are electric double layer capacitors, and they utilize matching electrodes of activated carbon typically currently, and they use ion adsorption charge storage mechanisms for both electrodes. They typically can store energy at higher rates and higher efficiency than batteries, and they also last many more charge cycles, hundreds of thousands of charge cycles typically. But the weakness of an ultracapacitor, or at least the current generation ultracapacitors, are around the value proposition fundamentally. They're very heavy. So their energy density basically is relatively low. relative to the applications that one would want to accelerate the marketplace. Otherwise, they're very expensive, and there's a fair amount of system complexity to run them. So the zinc-ion capacitor is something that's very new. It uses one ultracapacitor-like electrode, but instead of activated carbon, it's actually a functionalized nanocarbon that we've developed. And it pairs this charge storage mechanism with metal plating, in this case, zinc plating and dissolution processes. Right. So fundamentally, what happens here is we preserve the benefits of an EDLC, but we actually increase the capacitance of one electrode, in the case of the cathode, about 8-fold versus current generation EDLCs. And in the case of the anode, which isn't specifically a physical anode, it's more, it's the ions that are contained in the electrolyte. So we provide on the order of 2,000 times the amount of capacitance versus EDLCs in the anode side. And we also have this 3D nanofilm technology that can be used as well as part of this type of family of devices that further increases the energy as well. And it basically is a nanoscopic film on a carbon substrate. So it's another means of functionalizing the carbon for the cathode. And so it allows the ability to extend nanoscale materials to the micro or to the macro level. So the breakthrough that this technology really provides at the end of the day
10 seconds.
Is that it allows the existing companies, batteries, capacitor manufacturers, to leverage existing plant to create a device with 5 times the energy at 1/25th the cost, and system complexity reduced tenfold.
In time. Thank you. So
Didn't get to the second slide.
So we'll move right into the questions. So any order, would anyone like to jump in and ask the first question?
Sure, I'll jump in. So I'm a little lost. You have your own carbon, nanostructured carbon of some sort that has high surface area, let's assume. You have a zinc ion electrode. Is that a liquid electrode? And then I don't understand, in that figure, where's your nanofilm?
Right. So the zinc actually is contained in a multifunctional electrolyte, right? And it's actually deposited to metal on what you see there on the anode substrate. The 3D nanofilm actually is one version of a functionalized nanocarbon. And we don't show it here because we have 2 slides, and you can see that if I started talking about that, we wouldn't have gotten through the first one. So
the 3D nanofilm is carbon.
The 3D nanofilm is a nanoscopic film, thickness of film, that's conformally coated on a 3D structure, which is, the 3D structure is carbon.
Okay. So where is your benefit coming from? Is it the ion charge on the zinc itself?
Well, there are a couple of technologies at play here, and I don't want to sort of get too far down that path. I'd be happy to share the details with you. There's a little much to cover in this particular format, unfortunately, but I can tell you that the technology so far has been developed under a series of grants from NASA and from the Department of Energy, and also from the state of Maryland. So some of those technologies are applied here, others are applied a little bit differently.
Next question, Willem.
So what type of prototypes have you built so far to demonstrate those claims?
Right, so we built a lab cell, and the lab cell has been cycled 50,000 times without any degradation at all in capacitance, and at 99% charge efficiency. It's also been tested to minus 30 degrees C, operating.
Question, Gail?
Yeah, so Fraser, these increases in energy density, build cost, system design complexity, 5x, 25x, are those compared to the current state-of-the-art of ultracaps? Is that what you're suggesting here?
That's exactly right.
So how far do they still lag behind batteries?
Well, if you look at the cost, of a battery, say for example, are you talking about the cost, or which of these parameters?
Energy density in particular.
Okay, so energy density of a battery is typically going to be what? 250 watt hours per kilogram, say for example. Well, an EDLC is typically around 5 watt hours, 6, 7 watt hours per kilogram. We're looking at 25 to 35 watt hours per liter. 15 to 20, 25 watt-hours per kilogram. So very similar to what lithium-ion capacitor researchers are pursuing right now, but without any of the headaches, basically, because we use a water-based electrolyte. Very, very simple, very, very scalable, uses all of the same technologies that lead-acid battery, alkaline batteries, and electrolytic capacitor manufacturers already know how to use. So.
Final question, Nikhil.
Yeah, since you couldn't get to your second slide, I'll ask you a little bit, what's your commercialization strategy?
Oh, thank you. Appreciate that. So basically, it's a three-phase, plan, if you will. The first is the technology development, and we've received over $1 million in grants to bring that forward. We partnered with people that I mentioned, Naval Research Lab and Florida State University as well. We have 3 patents that have issued, 3 that are pending right now. Next comes the pilot capability. We're looking to raise a $5 million in a Series A to bring the product development into play, completed, and also get the materials in the cell at pilot scale. And then beyond that, we're looking at doing materials manufacturing and then licensing. So the IP licensing would go to existing battery and capacitor manufacturers, and ultimately we would be a cell ODM, at which point we would be running that through contract manufacturing, basically outsourcing that model.
This one's on time. Okay, and we'll move right into the feedback. So any order. Bilal, would you like to start back at the end here?
Sure.
Takeaway advice.
I would just, this is more of a advice for the pitch itself, so to say, that, the structure of a capacitor, you should assume, if the person is talking to you and you're looking for money, they should know what a capacitor, ultracapacitor looks like. Otherwise, they're never going to get there. So you're wasting your time with somebody who doesn't even know what ultracapacitor is. Given that they know that, then you should really point out what the key differences are, and which you completely skipped over. Like, it sounded like you're making a pitch for the world should have a better ultracapacitor, and I have one, which is fine. But I think I would have liked to hear, well, here are the 3 things we do differently. We have a double ion, we have an aqueous, because it raises a lot of questions in my mind. When you say aqueous, it has a huge implication for what this can or cannot do. So I would just, given that we are focused on technology for this pitch, I would just go right there and leave aside, everybody understands that everything needs to be 5 times or 10 times better than it is today, whether it's batteries or solar cells or whatever. Just say, this is how I'm going to get that.
Great.
Feedback, Willem.
Yeah, so I think it would be helpful to know sort of, your 5x, 25x, 10x, is that good enough, and sort of what's next, and sort of where are you on the curve, because, assume it's a very competitive landscape, and then if I invest in this technology, you have a state line, so how far can you stretch it with the innovations you have in the design? And then on your manufacturing strategy, I think you have to be careful to say, well, I can license it out to multiple people, and I can become my own sort of OEM in manufacturing these, and it's like, well, people license in, they don't want to create another competitor. So that I think the licensing out business model might be challenging to get enough revenue back. And you might want to look at a strategic partnership earlier to sort of get that access. And the manufacturing, I think, might be more complicated than you might look at it initially.
Feedback, Gail?
Yeah, I just wanted to build on what Bilal said, but maybe expand a little bit. I'd be interested beyond the technology and what the real value proposition would be for this. In combination with a battery in an HEV market or whatever it is that this huge increase compared to the state of the art in ultracaps is going to enable that's not already enabled.
Right. Thank you.
And Nikhil, takeaway advice.
I think most of the comments I would have had have already come through the panel. The one thing that I would comment, and Willem touched on a little bit, but I think it'd be worthwhile to get into a little bit more of the resources, the team, the types of partners that you will need to advance on your commercialization strategy, because I think that becomes a big piece of the equation here. An investor is going to want to see that you've thought through those elements and have some of those relationships lined up.
We do, but thank you for the prioritization. I appreciate it.
Gotcha. Well, thanks, Fraser.
Thank you.
Great job. Round of applause. Fraser from Ionova Technologies.
So next up, and this is the last one before a short break, is Ruaridh? Ruaridh. Macdonald.
Should I just wait 2 minutes on the slide change?
Yes. Sounds good.
from Open Water Power.
Good.
Go right ahead.
Hi, I'm Ruaridh from Open Water Power. We're a team of 3 MIT PhD students.
Speak right into the microphone.
Who over the past year have developed an aluminum water fuel cell that can store 40 times more energy than lithium-ion batteries. Between ourselves and our advisors, we have multiple exits, and totaling over $100 million. Today I'm going to talk to you about how we're going to bring this technology to market and revolutionize subsea power. So, energy storage is a significant challenge still facing many industries. The lithium-ion batteries have poor energy density and are unstable in many adverse conditions, as the grounding of the Bowen Dreamliner showed us recently. Aluminum, on the other hand, is the holy grail of battery materials. It's the most abundant and energy-dense material in the world, and can store twice as much energy as gasoline. Now, most of you will have noticed that your soda cans don't set on fire whenever you get them wet, and that's due to a nanometer-thick layer of rust, which prevents oxidation. And so what we've done is we've developed liquid metal additives that allow you to disrupt and remove that layer of rust, and then use the aluminum as an anode in a fuel cell. As an anode in a fuel cell. That rust layer is what's prevented any previous attempts to commercialize aluminum energy, but the additives we've developed are safe to handle, inexpensive, and work at room temperature. Room temperature. Sorry, brain. Sorry, if you don't mind, room temperature. There are no other energy sources that can currently compete with us, both economically and by an energy density scale. We have the most technical advantages underwater, where the only really other option is lithium-ion power. And we can run on seawater, and all of our exhausts are safe to dispose of in the ocean. Next slide, please. So, using our... completely fucking... using our... I'm just going to... Sorry.
Go ahead. It happens all the time.
30 seconds.
30 seconds. All right. Wow. All right. So our technology is the greatest technical advances underwater. Lithium-ion batteries have low power density. Diesel requires large amounts of oxygen, and hydrogen fuel cells require large amounts of hydrogen, which are both explosive. Our aluminum fuel cell has none of these risks, which allow large amounts to be stored on the surface vessels or underwater. We're already partnered and initially planning to sell to the Navy and oil companies, as both are heavily investing in UUVs over the next 10 or more years.
And time.
Gosh.
Moving. Great job.
The Q&A is always much easier.
Yeah. Anyone jump in? Who has the first question?
So you mentioned you're currently at a 10x density of lithium ion, and then you say I can go to 40. So what's that 10 to 40? What's that based on or dependent on for you to realize that?
Our current prototypes are sitting at about 25% of the total efficiency that we think we can get eventually. And so that's just a case of our development continuing.
Yeah. I can totally sympathize with, this 3 minute. I wouldn't be able to explain what I do in 3 minutes, let alone describe the technology. I didn't quite understand, is this a primary cell? I understand that lithium is a single ion and aluminum has 3+, so yeah, that's great. But is
it's
it
a fuel cell or primary battery currently?
Okay.
We are looking at some ways of turning it into a secondary battery, but those are far down the road and not what we're looking at right now.
Got it, because that would have been my big question, because getting 3+ ion mobility is tough.
So right now we mechanically recharge it just by swapping in a fuel cell, a chunk of aluminum.
Yep.
Other questions? Gail?
Okay, I'll ask my intellectual property question again. What's the status?
We've already patented through the TLO and finishing negotiating those licenses.
Question, Nikhil?
Yeah. Can you talk more about what sort of specialized needs or requirements you're expecting for the underwater applications that you need to design towards?
So we're currently designing them to just slot straight in for the lithium-ion batteries. For any average user, as in like a day-to-day user, they just need to handle aluminum chunks. So there's no They don't have to get in touch with anything more complicated than that. And for maintenance, you might need to replete, while the additives aren't depleted by any way in the fuel cell reactions, there can be, small amounts might get carried out with waste. So some technicians might need to replenish those, but those are negligible amounts.
Can I ask one more question?
Of course.
So you keep mentioning lithium ion. If it's a primary cell, primary battery, doesn't need to be lithium ion, right? I mean, why is that the competition? You could be using, a lot of metal air batteries, metal water batteries. There's a lot of other things that oil and gas industry uses that, very expensive, but they last forever. They have huge energy densities. Lithium ion is special because it has high energy density, but it's rechargeable.
Sure. So we mainly compare to it because it's what's used in the widest range of applications. And from what the groups we've been working with, the current UUV vehicles use lithium ion. So that's another reason we've been making direct comparisons. And we're trying to, in order to reduce our development time, we're trying to work as closely as possible with them on our first product, because we think the UUV market, given that, and I guess this would have been in my speech, but how high margin it is, and like the strong potential for growth once they find high endurance power sources like ours, we thought that would be a good springboard to then enter other markets where perhaps we're not comparing to lithium ion. Because one thing that we don't address specifically in the slides is that once you're on land and using land-based applications, one of the non-toxic exhausts is hydrogen. So once you have a secondary supply of air, you can double your energy density again.
So, Gail, would you like to start with the feedback?
Sure. You can write the first word of each paragraph on your hand.
That was strongly recommended.
No, actually, you recovered beautifully, so no further feedback.
And Nikhil?
Yeah, I would didn't really get to this in the Q&A, but in your timeline you talk about shipping prototype end of year 1 and shipping product end of year 2, which seemed quite aggressive to me, just based on past experience with relatively similar technologies and commercialization cycles. So I think getting into a lot more detail in terms of mapping out that time frame and the steps required and reviewing that with your prospective customers would be an important step here to set expectations appropriately for the development here.
Sure. Thank you.
Other feedback?
Sure, I can go next. I learned very early on to never memorize a pitch. So just, say whatever you have to say and don't even worry about what you were supposed to say. I think I'll go back to the question I asked and just say that as feedback, that I think you are, this is just my perspective today, hearing what I heard, that you're comparing to lithium ion because you can show your 10x and 40x, but lithium ion is probably being used because those are rechargeable applications. And nobody's going to buy a non-rechargeable battery where they need a rechargeable battery. You should really be comparing yourself to the non-rechargeables and how much energy density they have to make sure you're doing apples-to-apples comparison. And you might still be great. I mean, maybe only 1.2x better, but that might be enough for somebody to switch over. Just to make sure that you don't end up with the apples and oranges comparison, and at the end, the product doesn't have the value prop that you thought it would have for the customers.
Okay, thank you.
And takeaway advice, Willem.
Yeah, so I think a key is whether or not sort of the technology at risk that's still there. If you say, if you're selling it as 40x, then that's how you get sort of your first customer engagement, to saying, from where you're at, how to get there, and understanding those limitations, because it doesn't look like a very simple technology. And then again, if you go to, existing applications in these underwater exploration activities, I mean, there are currently solutions that last pretty long, but then speed is a big concern. And so if you get more power in, what are you really enabling with the power versus what you currently can do of sort of bring it to the surface, recharge it, and go again. So I think an operational scheme, and then go beyond, so your first application, which is always going to be a relatively niche application, what's next for the technology if you really make it work as a more of an integrated fuel cell.
That's great. Round of applause. Good job, Rory. Well done. Okay, so now we're just we're gonna stop now. We heard 4 pitches. We'll resume in just a moment. We're gonna take a quick sponsor break. We'll let you stretch your legs for 5 minutes, and then we'll have the final 4 pitches. For the sponsor break, we're just going to hear a few words from Willem around Shell's GameChanger program. So, Willem, tell us about GameChanger.
Yeah, so again, just Shell GameChanger is a externally focused collaboration program that Shell has, where we provide seed funding for novel ideas, both in future energy and traditional oil and gas. And anything business model, we do business model and technology, and a very flexible type of funding, what's needed for the people that bring in the idea, or we do also cross-industry, where people can demonstrate their technology for an application they think is of interest in oil and gas. We do have a bound scope that it should really fit, strategic business area of Shell. We always like to say, just because we sell gasoline or because we sell chocolate at a gasoline station doesn't mean, we need to develop our own chocolate. So there are limitations in what we do. So if you're interested, just come up, talk to me, or go to our website, www.shell.com/GameChanger, where you can submit your idea, and then we evaluate it or target or bring you to the right people within Shell if it doesn't fit our program. So our criteria are really high-value applications, high level of novelty, off the beaten path. There has to be a doable plan to demonstrate the concept in a reasonable amount of time, reasonable amount of funding, and it has to fit, within the Shell business strategic space. Thank you.
Thanks, Willem. So for all of you who are working on an energy technology, come and see Willem at the break, or also at Mead Hall afterwards, and tell him about it, because that's what he's here for, to hear your energy technology ideas.
That's great. Thanks, Graham. Thanks, Willem. The next up, we'll just ask Chris Lulier of Mintz Levin to come say a few words. Mintz Levin has been a long-time sponsor. I think it's been about 3 years. Yeah, Chris, if you could just grab that mic down here. Assume the position. 3-year sponsor of ultralight startups. Chris Lulier, tell us about Mintz.
Hello, everyone. Good evening. My name's Chris Lulier. I'm an attorney at Mintz Levin in Boston, and it's been 2.5 years since I met Chris and got involved with ultralight. And my firm's been sponsoring ultralight for about 1.5 years. During that time, we've developed a really solid relationship with Graham, Chris, and the entire ultralight community. So we're pleased to be a trusted resource in that network. So Mintz Levin is a law firm of about 450 attorneys. We have 8 offices in the US, Europe, and Israel. Excuse me. So we're a relatively large firm, but we're committed to working with the startup community. We've worked with ultralight companies on intellectual property issues, contract issues, corporate issues, data privacy and security issues, a number of other issues. So we're particularly excited about the event tonight because of the subject matter, future energy. Mintz is one of the country's leading providers, Mintz has one of the country's leading practice groups in energy and clean technology. We currently have over 300 clean tech clients, both on the company and investor side. And we've closed $7 billion in deals, clean tech deals, in the last 6 years. So we know this space. So we're into startups. We know clean tech, so it's a perfect combination. So anyway, if anyone has any questions, feel free to ask me, and good luck to everyone who's pitching. Thanks.
Thank you, Chris. And now I'll just ask David Ulrich of WorkBar Boston, the original birthplace of ultralight startups Boston. So David, if you could tell us a few words about WorkBar.
Yeah, so this good. So first of all, I'm kind of interested if anybody, or who's been to WorkBar, who's a member, who's heard of it at least. Yeah, okay. That's kind of interesting. A lot of people haven't. That's good. So I'll explain it to you. So what WorkBar is, it's a, can I do this?
Just rip it right out.
It's a shared office space, community office space, or co-working space, call it what you want. And we work kind of like a gym in that we offer you a monthly membership based on your needs for your workspace. And what you get, we provide the obvious needs, printers, faxes, of course internet, and of course a desk. But what we found is the most interesting part of it is that people, although yeah, people work differently now and they need a desk, they don't want to work at home, what they find the most sort of compelling reason to go is more to the community aspect. And we've developed quite an interesting community there, from startups to self-employed, all the way up to people working for rather large public companies. And it's kind of interesting how they get along, in that they become not only coworkers in the social sense, but also you can see collaborations happening from even between people working for these very large companies down to the very small companies. And we are located in Boston, at right across from South Station. And due to our enormous growth, we're now opening up a new location in Cambridge. Hopefully everybody here is familiar with Cambridge, obviously. We are down the road, down Mass Ave, and Prospect, right in Central Square, right off of the T. Basically, everybody familiar with the bar, the Field? Yeah, maybe not, all right. Maybe you forgot about it. Anyway, so we are opening the 1st of next month. So I invite everybody to come by. It will be real easy to find because we'll have a sort of cafe level. Come in, grab a coffee, work, check it out. We have cafe level on the entire 5th floor, so there's a great view there. So I encourage everybody to come by and check it out. 1st next month. Awesome. Oh, I also forgot to mention that, like Chris said, this is where we started, in the Atlantic Ave location, the Work Bar in Boston. It was kind of fun. We did, well, the screen was a little smaller then. It was before we expanded there a couple of times, and we'd sit there with 20 guys just streaming the New York events, and that was kind of fun. But it's real interesting to see how it's grown. Good job,
Great.
man.
Thanks, Dave. Thank you, Dave. Thanks to all our sponsors. Okay, so now it's literally a 5-minute break, no more. So this is a chance for you to just stretch your legs. Do not leave the room. For the folks that do not leave the room. For the folks that don't have a seat, now's a chance for you to get a seat. And we're starting in 5 minutes. Introduce yourself to the person next to you.
Not to hurry Willem along, of course.
Okay.
That was the connection. That was it, right there. That's going to change our energy future. I can feel it. Okay, Ganesh of SmartPwrNet.
Right, I'm sure they do.
You have 3 minutes. Go ahead.
Hi, I'm Ganesh Nakhawa, co-founder of Abitech Solution, introducing Smart Power Energy Monitoring and Controlling Solution. We are seeking for investment of $325K. SmartPwrNet measures real-time building and equipment efficiency that reduces 25 to 30% on energy bill by monitoring thermal and electric energy. We also manage heating and cooling for furnace and air condition. Our solution offers easy-to-use data collector to monitor electricity, smart sensor and controller to manage thermal energy, and smart adapters that can control devices remotely. All these devices can be managed through Smart Power Analytics software, where you can control all devices and monitor the energy utilization report that will guide you and identify the problem with your energy solution, and you can basically find the solution for that. Study says that heating and cooling consume more than 50% of energy utilization from your building. So if building owners can manage and control that wasted energy, then they will have positive impact on their monthly bill. So today, energy monitoring solutions are expensive, and most of them are focused on electric monitoring only. But SmartPwrNet offers affordable thermal and electric energy monitoring and controlling solution for HVAC system and electric appliances. With our solution, you can create virtual zone without disturbing existing duct. Our customers are commercial and residential building owners to whom SmartPwrNet offers innovative, affordable, almost half the cost of our competitors, and easy-to-use energy monitoring and controlling solution. that will reduce your monthly bill by 25 to 30%, and it will give you ROI within 8 to 12 months. We will make money by selling hardware with one-time charge and monthly subscription, $7 to $10. We also help green initiative and create jobs for contractors. We have developed hardware and software simulation and
10 seconds.
We are in process of, we already filed 2 patents on our technology, and our solution is the only affordable solution today in the market that can control electric and thermal energy monitoring solution.
And time. Thank you. So we're going to move right into the questions. So any order, who would like to jump in and ask a question?
So I'll start, Ganesh. 325K is an odd number. What do you envision doing with that money, and where will it get you?
So we have done like simulation for hardware and software. So we want to build prototype and build the products for our future.
Speak into the microphone, guys.
Yep.
So what's unique again about your technology, or what you really know? I don't want to steal Gail's thunder about IP, but sort of what do you have that can be protected?
That's a good question. Most of the solution in the market, they have electric monitoring, but we are providing electric as well as thermal energy monitoring. And that's our IP, and we have developed the hardware as well as some software algorithm which can monitor and measure the energy.
Okay. And so you envision a monthly subscription model. So is there enough cost savings in what you offer to justify spending that amount of money?
Sure. So we have a different approach. Like we have like monthly subscription. Also, if you add on to additional devices, we can also charge separately. So altogether, we calculated it. So first year, we will have break even, but after that, we will make money. So we have that financial already done with that.
If I could ask another question,
Sure.
how are you claiming the 25 to 30% energy reduction? Is that just making the owner or owner aware, or are you implementing some kind of control strategy to manage?
So we already did simulation, and based on that, we believe 95% of accuracy with that simulation, and we can achieve that 25 to 30%.
But what were you simulating? Were you actually managing the energy use, or are you just making the customer aware of their energy use?
No, we are monitoring as well as controlling. So we have IP, which is monitoring and controlling thermal energy. So that's how we will calculate each and every room's energy utilization, and then we also create cumulative reports for building audits.
And Ganesh, sorry. What's your distribution strategy? Are you going direct to customers? Are you going through channels? Are you white labeling? What's your intention here?
So we have a couple of options. So we will use direct marketing. We will have distribution channel. Also, we will have partners with real estate owners and real estate association where we can pitch in our solution, and they can give us a channel to reach out the customers.
So you intend to be a consumer-facing brand?
Exactly.
Question, Bilal?
Oh, I was just going to ask, well, that was my question, but Nikhil stole it.
Sorry.
Good question.
You're welcome to move right into the feedback, Bilal, if you'd like.
Well, so let me ask quickly a question. Where did you come up with the $7 to $10? Like, how did you come up with that number?
Because we did competitive. Yeah, our competitors also charge that, but at the same time, we calculated our financial aspect. We want our solution to be affordable to our customers. So we are not going to charge on hardware too much, because if you look at it, our hardware is almost half the cost of our competitors. So we will charge like monthly subscription, but we'll add on services like.
Okay, so I'll give the feedback. I think if there was to be an example of a company where minimum viable product makes a lot of sense, this would be it. I would not make any hardware. You could do almost everything that you're talking about with commercially available hardware that you snap together. I would test out your distribution model using that. And I would also, by the way, figure out if anybody gives a damn about the electric solution or the differentiation is really the thermal solution, and just offer that. Let other people who are spending a lot of money creating the best solutions for electric, figure that out. You know, you need to try out to make sure that the savings that you think you're getting in your simulations will be real, and then does anybody buy that? It might be a little bit expensive in the beginning, but you need to have enough evangelists that really care about this to know that there's something here. Before you spend money on designing hardware that might be better, but really is, I mean, you know, this is commodity hardware at the end of the day.
More feedback, Willem.
Yeah, so I think, you know, my question is really, how do you make this sustainable for somebody? If you come in, you identified savings, people change, because then really if you want to change energy or save energy at your house, it's a lot to do with behavior. And so I'm not sure whether your solution brings that element enough in, and then if the novelty wears off, then, you know, what are you going to do with it? And are people then still interested in keep paying that subscription because they really need to recognize those savings? And I'm not sure whether, you know, depending on, you know, which market you're at, you know, I'm in Houston, so the heater doesn't run that often, so that thermal integration is probably not that interesting. And once I figure it out, sort of it's a cost-benefit analysis where you really have to offer something and get people engaged really in energy savings, I think, if you're targeting these types of solutions. Whereas a commercial, you might have more opportunity or do a business model around, you know, proven savings or something like that.
Feedback, Gail?
Yeah, I think this is a very, very competitive space. And I think if the thermal management is going to be an advantage, it would have to be in a commercial segment where thermal use is something beyond heating and, you know, so food service or something where fuel is used for something, because the smart thermostat accomplishes the thermal management, if you will. So I'm not quite getting the value proposition more generally, so I think you should give some thought to that.
So
and there's no response to the feedback. Just take it away.
That's not fair.
And take away advice, Nikhil.
Yeah, couple things. I tend to agree with you know, I guess parsing between Bilal and Gail's comments that to the extent that there's differentiation, it is going to come through the thermal application, the thermal features, but I guess somewhat different from Bilal. I think if you have a clean integration of the electric and thermal, at least from a consumer application, I think that could be potentially interesting in terms of presenting a comprehensive solution. So, you know, I agree that there's a lot of competition in that slice on the electric. So I don't have visibility into how good your solution is there, but you know, potentially it does make sense to keep those two together. The other thing that I would just point to is it is a highly competitive space, and I think that one of the key challenges here really is the distribution side. So it is no small deal to have that distribution partner, and you're seeing a lot of big names across a variety of industries that have consumer and commercial presences getting involved here and seeing this as their next big opportunity. I suspect your $7 to $10 a month after you're done going through those guys might look like $2 to $3 a month at best. So I would think about different business economics there as well. But regardless, that partnership is probably going to be critical for you to have you know, that chance of scaling.
Excellent feedback. Round of applause for Ganesh at SmartPwrNet. Great job.
Thanks, Ganesh. And next up we have Drew Hession-Kunz. And on deck we have Bal Mukund Dhar. So Drew of Gravitas Energy. Go ahead whenever you're ready.
Gravitas delivers grid-scale electricity storage at 1/3 the cost of current technologies. This allows electricity generation to be maximized in efficiency separately from the demand component of electricity generation. The ancient Greeks taught us that the wheel and the incline are a powerful set of tools to do work. To that we add a sophisticated magnetic axial linear synchronous motor to store energy using gravitational energy as an analog to pumped hydro, which is most of the storage market today. We take in electricity from the grid during times of excess production and consume that electricity to push massive concrete blocks up the incline, which are then stored at the top of the hill. At times of electric demand, we drive those back down, regenerating 90+% of the electricity that we use to get the blocks up there in the first place. So we have the simplest possible technology married to a very sophisticated approach to store grid-scale quantities of energy, and that's Gravitas. Next slide, please. I think storage is the most interesting segment of the market in the energy field. I'm Drew Hession-Kunz. I am a serial entrepreneur. Recently was with Innovex, which we sold to Olympus for a 9-figure outcome. And we pulled together a very strong team to deal with this very large-scale, grid-scale storage problem. And I understand the trials and the tribulations of dealing with a very entrenched, highly regulated market. Compared to pumped hydro storage, as you can see here, our facilities, their facilities take many years to build, often a decade or even 2, consume large amounts of space and money, and ours can be built much more quickly at far lower cost, and because of our smaller footprint, can be built close to major population centers here in Europe and Asia. We're seeking a $750K angel raise, which is our first outside money, which will be part of about $12 million to get us to our first revenue. And we're looking for partners to join our team to help us through this process. Thank you very much.
Great job. Okay, moving right into the questions. So any order. Willem, it looks like you have a question.
Well, I was just comparing it to a nice ski lift, you know, that sort of a ski train that goes up and down the mountain.
I think that's what got us the idea.
And I guess, yeah, but so I guess I could build that today. So where I'm struggling a little bit is saying, okay, what is it you need? Whereas, you know, so I think it's more in the metrics, I guess, for this, how much energy can you really bring up and down? And then the question is, so how fast can you change between charging and uncharging?
Yes. So excellent questions. We can store, depending on the size of the storage parking lot at the top and the bottom of the hill, a gigawatt hour, 2 gigawatt, 3 gigawatt hours. The rate can be in the hundreds of megawatts of energy either in or out. If we're sitting at 0, it's right now about 12 seconds to go from 0 to generating energy or to taking energy in. And we're working on a method of shortening that up. Which we'll also look to patent as well, but it has a little ways to go.
But so the concept is actually to unload and offload these blocks, or you keep them on the carts?
Yeah, they're actually load and offload at the top of the hill. And that incline is about 2,000 to 3,000 feet, so that's what sets us to not an infinite number of locations, but a substantial number of locations near major populations.
And where does the $120 million come from?
That's a combination of the costs for the land.
What went into that number? So how did you land at $120 million?
Oh, basically figuring out the build, the technology, the blocks, the land itself. So it's full production cost, and we've worked with civil engineers and people who've built power plants. We have a guy who's coming on the board who's built several. We have civil engineers that we've worked with, so it was basically developed from a projection.
Other questions? Bilal, question?
So, gigawatt-hour storage?
Yes, sir.
How many of these are getting built every year? And
Right.
why are you comparing it to peaker? Because I see a number of peaker here. Because peaker plants, you know, I mean, when people talk mostly about bulk energy storage, they're talking about, you know, 5 megawatts for 8 hours. Maybe a gigawatt is like you're replacing a coal power plant or natural gas full-scale power plant, not a peaker power plant.
Correct. Just to give a range of pricing. So to compare to the pumped hydro, this is really a physical analog to pumped hydro, which is the 98% of the storage market today. And it puts us on, at least on size, the gigawatts. The biggest ones like Bath County in Virginia is 3 gigawatts. And that gives us a sense of the scale of storage that's currently being used. There are about 40 plants operating in the US, something similar to that in Europe. And there's another 38 that have permits in now. So our goal is to, that's our target, is that size and scale of market. Our efficiency, because of our drive system, the efficiency goes dramatically up because of the scale. That's really what
Are you saying 90% is round-trip efficiency?
Yes.
Okay, we're gonna move it on just to be conscious of time. So other question, either Nikhil or Gail.
Yeah, I guess I'd ask you. I mean, understanding that you're patenting different elements of this, ultimately, how defensible do you think the overall solution is? There's elements of this which would seem somewhat obvious to other groups, and there are people doing the ski lifts and locomotives up and down hills and things like that. So similar types of efforts are underway. I guess I'm curious, is this a technology play or a project development play from your standpoint?
I think your point is well taken. Despite the patents that we're working on, there are lots of ways to tackle this problem. So the defensibility is not super high, but the hurdles is partly that it's a project play. It's that it's large scale, and that as we develop partnerships, I think that will give us a lot of strength. Part of it is this is really a hedging model and a time shifting as well. And so whoever's really big and in place first consumes the hedging market, and after that there isn't a hedging market. So there's a certain speed to market and a certain being firstness that helps.
Okay, so Gail, if it's okay, could we move straight into the feedback from you?
Sure.
Would that be all right?
Yeah. Yeah, I'll turn my question into feedback. So,
thank you.
So yeah, when I heard about this, I was thinking, how many 3,000-foot slopes near urban areas where you could get the real estate you needed and overcome the permitting issues and all that could there possibly be out there? And so I'm still curious about that. You've apparently done some analysis to lead you to believe that the potential locations are many.
Substantial. Florida's right out. So.
Yeah, I would think, yeah. So I guess my feedback would be characterize that a little bit for the people that might have that question.
Thank you.
But didn't get to ask it.
Thank you, Gail. Other feedback?
Yeah, I guess, feedback building on the question and answer that we went through a little bit, but if you see a lot of the opportunity here around the deployment and project development piece of it, I would look at casting a very different set of metrics, perhaps, in terms of thinking about project IRRs, the equity capital versus leverage you need to put into these projects, what types of investors might look to deploy capital here, because that's a very different business model than technology development. So. I think some of the metrics you have here are useful, but don't fully cover what the market would need to understand.
Thank you.
Go ahead, Willem.
Yeah, so I think a good partnership and which market you're really trying to address. I think it's one of those things where people say, yeah, with more renewable storage will become important, but is it really true, or what's the true market of sort of bulk storage and get it out of the arbitrage, rather than focus on, say, okay, if more and more states require integration of renewable energy, how do you balance that, and is there something in that market sort of on the integration, and then that might be able to get you away from having to load and unload these blocks and see, is there something simpler I can do on a much smaller scale that proves my concept and with my efficient drivetrain and still create value around integration rather than bulk storage. So that's really what I would explore, and then see where sort of in the US at least people are actually looking for those types of solutions or running into problems integrating renewables. So attach yourself to that market.
Thank you.
And takeaway advice, Bilal.
I'll give it the way that it was framed, that what would I do if I would wake up the next morning and I was the entrepreneur doing this? I'm having a very hard time believing the numbers. 90% plus round trip efficiency, cost numbers that you have, then reaching 5 cents a kilowatt hour. And doing so at a 2 gigawatt hour type scale. These are, in my opinion, unrealistic numbers, but let's assume they're just aggressive targets. You've got to be really sure of that, because there doesn't seem to be a small way of testing this. Doesn't seem to be something that you could build on a local hill in Newton and test that, right? So I would really be very, very critical of those numbers, because, the only way to do this is to put $100 million into the ground. And I'm having personally a very hard time believing that these numbers are possible.
Round of applause. Great job.
All right, thank you.
Thank you, Drew. So next up we have Bal Mukund Dhar. Hope I'm pronouncing that somewhat closely. And then the last pitch on deck is going to be Jacob DeWitte. So Bal of Agira.
So good evening, everyone. I'm Bal Mukund Dhar. I'm the co-founder and CTO of Agira Inc., Agira Energy now. I'll keep it very simple. We started as a solar cell company in 2011. The market crashed and we had to reinvent ourselves. And so, this technology is the technology that came out in adversity. And what it basically is, in simplest terms, is that you take a sheet of glass and imagine all the lights that falling on it gets guided to the edge or the edges. And if you mirror it, it comes to one edge. And the real secret sauce here is that you can do this at multiple angles of incoming light. So sun going morning to evening, sun going summer to winter. So you totally eliminate the tracking that you need to guide the light into the sheet. And once it's in there, it's trapped in there. On the edge, you can put a solar panel and solar cells, basically, finished solar cells, and you can produce power. We also have a way to turn this optics on or off, and which basically means that if you put it in a smart window, this will be the first of its kind power-producing smart windows that will also act as electronic blinds. So imagine having waking up in the morning, turning on your iPhone, and turning on your window. And when it's actually producing power, when the window is in blind mode, it's actually producing power. All right, so the benchmarks we have set for ourselves, because we have to be profitable in a competitive solar market also, is 80% of the light that falls in should get trapped. And in simulations, we are around 50%. In practice, as prototypes, we are around 33%. But we do get waveguiding at multiple angles. In principle, we'd like to get 1000x, but the way this technology scales up, you can go any number of x. You can start from 5x, you can go to 10,000x, not a problem. And you can switch it on and off. We don't need to track the sun, so that's a huge saving, and these are just really thin. So they're not bulk like other solar concentrators. They don't need to track the sun. So you can essentially take these sheets and put them on your rooftops, just like you put other PV panels. Next slide, please. So we have done prototyping. We have done some simulations. We are doing more of it. We have just hired an experienced CEO who also has a physics background, optical physics from Columbia, and 15 years of clean energy experience. And we have a couple of grad students at MIT who are helping us with a lot of stuff. And we are semi-finalists at MIT Clean Energy Prize. Customers are going to be residential and commercial.
10 seconds.
And we're going to focus on the smart window in the longer term, 2017, and solar panels in 2015 for a short term. And we're going to have a retrofit solution coming up next year.
And time. Okay, so we're going to move right into the questions. Thank you. So Gail gets the first question. Go ahead, Gail.
Thanks. Yeah, I think I've heard about a lot of companies doing very similar things, but you say first-of-a-kind power-producing smart windows. Talk about the competitive space a little bit. Seems like there are a lot of folks out there in this world.
So most of the technology is something like electrochromics. Mm-hmm. So you change the color, you pass current through it or voltage through it, and you change the color. So you apply, you give the window energy to block incoming light or your heat or something like that, infrared. Here, this works for, this actually is a waveguide. So basically, the light that's falling on it is just not reflected away. It's actually trapped. And it doesn't use any exotic materials. It's just plastic, glass, silicones, regular materials, highly scalable. Injection molded optics, basically, that can go on top of a glass sheet, that kind of stuff.
Question, Nikhil?
Yeah, I guess first off, great presentation, and good to hear about bouncing back from adversity. I think that was a good transition for the business. I guess I would ask you, at a high level, in terms of what your target market or opportunity is. I mean, you talk about solar panels in the near term. You're effectively still competing on an LCOE basis. with the market, and you know, you're talking about getting to a cost below 50 cents a watt. I mean, that's probably not, you know, at that 50 cents or just below, that's probably not too far off in the future here. So, I mean, is that something you can really be competitive with as an intermediate market, or I mean, should you be looking?
We have an advantage here, and the advantage is that at 1000x we can also put high efficiency multi-junction solar cells on the edge, and so this could be a 30% efficient panel, and so you'll save it on balance of system. So this could be a product that solar project developers will still want in 2015, 2016 because of the savings that they'll have on the total LCOE, because the balance of system goes down.
Do you have any expectations where you come out on an LCOE basis?
So we're going to make it at 30 cents a watt. We're going to sell it at 50 cents a watt. Balance of system cost savings, if you add it up, it's going to be around $1 per watt, but that also depends on the the project developer himself.
But
so,
that's before
so
the
$1 per watt, total system cost should bring it to.
Does that include the high efficiency cell?
With the efficiency.
Okay.
Yes.
But there's a problem there, right? Because solar cells are mounted on top of your roof, facing the right direction at the right angle. Mm-hmm. You're positioning it at windows. There's probably only certain sides of the home that you would want to position them at. They're not always exposed as certain. I mean, there's a whole bunch of other that the direct sunlight that the solar cells are able to get, or even if it's diffused, but at least it's in the right angle, is just not available here. So your LCOE, even if you hit the same numbers, and I don't believe that the BOS numbers are going to be smaller here because you have lots of distributed sections, unless you're coating them on very large glass buildings.
I didn't get that. I mean,
you have small windows, right? So think of windows. You have every window will need to have an inverter associated with it and all the wiring that goes back, right? Unless you're creating some kind of a mega structure. Now, in the building windows, certain windows are facing the sun, but the rest of the windows are not, right? And the angles are never going to be perfect. They're always, you can collect at every angle.
So there are only 4 directions that you can face, or maybe 8 directions you can face. So, and there are certain latitudes that you work in, right? So, so when you have to position something, if somebody has to be sold this product in Arizona versus somebody has to be sold this product in Boston, your latitude has changed. So we'll just sell them a different optic. All we have to do is our injection molded plastic optic will be a slightly different design.
But $1 a watt gets you to the LCOE that you can get with solar on top?
Oh, of course. So the LCOE we are talking about for the solar panels, not for the smart window. Smart window is a great benefit. I mean, right now everybody in the market is talking about a smart window that saves you energy by reflecting off the light that you don't want or the heat that you don't want. But what if, on top of it, you can actually produce some power? That's great news, right? So for the smart window, because we are the first movers, we'll have the advantage of slowly building up to a point where we can improve on our efficiency numbers for that vertical profile or windows at different angles. Right? But for a solar panel, yes, the LCOE will work.
Go ahead, Willem.
So I had just a question about, you mentioned that, on the one hand you have focus on solar panels, on the other hand you mentioned electronic window blinds. Are these two linked? Or can you make, with your technology, can you make an electronic window blind and just forget about the whole solar power thing?
Absolutely. So that's what we already have made something like that. We are going to show that to our judges at the MIT Clean Energy Prize. And that's going to be our first product that will bring us money. And what it's going to be is a plastic sheet that you can buy on Home Depot. $30. You paste it on your window. With Bluetooth, you interface it with your iPhone, and you wake up in the morning, open your window. Yeah.
So, Willem, would you like to give feedback at this point?
I think I like that idea better than messing around with solar panels. So that's sort of where I think you might have more of a differentiator. I think it was commented on that there's so many people focused on solar and so much difference, even on the type of whatever you're doing and concentrating and linking it up with the windows. I mean, I've seen quite a few smart window plays or solar panels in windows. I think a lot of them are challenged, so they'll have a niche. Whereas the tunable blind, like you said, it might give you a first product, interesting market, interesting application. People like to do things from their iPhones. So if that really works at a reasonable price, I think that would be a first product.
Feedback, Gail?
Yeah, I think you mentioned at the beginning that this was a pivot from an earlier startup that didn't work out, and so I guess I would have expected that the learning from that would have gotten some of your questions answered around a go-to-market strategy, for example. So this looks like something that's, as we've been discussing, a very competitive space, probably going to take quite a bit of money in the long run. And as I think an early-stage investor would be hesitant to look at this when the money's going towards prototyping and developing a go-to-market. I guess I'm wondering why that's not already sort of established from the previous effort.
Well, and there's no response. Sorry,
You don't
just
get to answer.
just a feedback.
It's so unfair, isn't it?
It's a trick. Go ahead, Bilal. Feedback.
Oh, I would just say that what you said at the end had nothing to do with your presentation, which is weird. You know, it's like I'm going to be an electrochromic window that's tunable within current, so clearly I'm not going to buy a plastic sheet. I need to somehow wire it up that connected to a Bluetooth, some kind of a device that connects to my phone. You just kind of threw it out there as though I literally buy this paper, attach it, and it works. I think frankly, you should have talked about that as a product. And I don't know why you went down the whole solar path and having all my questions answered about BOS when you're really building an electrochromic window as your first product.
It's not an electrochromic window.
Okay. No
I didn't say that.
We'll take it up at Mead Hall. And feedback, Nikhil.
Yeah, I think there's a general theme, and I tend to agree that the smart window application is more interesting than the solar opportunity, the solar panel opportunity, that is. That said, that is also a highly competitive and capital-intensive space. There's a number, I'm sure you're well aware, there's a lot of players that have been heavily funded that have top-tier partnerships with leading window manufacturers and distribution channels. So in terms of thinking about that 500K, I would map out what that strategy looks like to commercialization, what sort of partnerships you need along the way, what sort of capital infusions, and take a good hard look if you think that's really going to be viable from given current market conditions.
Excellent feedback. Round of applause. Great job, Bal.
Okay, our last pitch tonight is Jacob DeWitte of UPower, also the last MIT Clean Energy Prize team. So Jacob, you have 3 minutes.
Thanks, Graham. Thanks, Chris. So my name is Jacob DeWitte, and today I'm going to talk to you about UPower, a team of MIT grad students and alumni in nuclear engineering with experience in high-tech startups, as well as our first-of-a-kind solid-state nuclear battery. But first, I want you to imagine that you are the base commander of 1,000 Marines in Afghanistan. Okay, you need a constant, uninterrupted supply of energy to power your operations so you can carry out your mission. To do that, you run diesel generators. So you have to refuel them all the time, meaning you are constantly airlifting diesel and trucking it in. In fact, you're likely burning 7 gallons for every gallon you receive. Well, that's very expensive, and it put lives in danger. So what if you had a generator that was always on, completely emission-free, and you only had to refuel once every 30 years? Not only would that save money, that would save lives. Well, meet UPower, the first solid-state nuclear generator for remote and distributed generation. We like to call it a nuclear battery because it produces 1.5 megawatts of electricity and can co-generate steam and process heat 24/7. It's fully containerized and transportable, no emissions. You can recycle the fuel after a 30-year fuel lifetime, and it has fewer than a dozen moving parts. Okay, so it's truly walk-away safe. So let me show you how it works. First, in our fuel, we use uranium or thorium to generate heat, which is carried by heat pipes to our power conversion system, where it is converted to electricity using thermoelectric generators. The heat that is not converted to electricity is then carried and transferred to the air by our radiators. So some of the neat things about this are that it ships in a 10 by 10 by 20 foot box, just a little bit bigger than one of those cargo pods that you can move and pack in. And it's plug and play, meaning you move it to where you want it, when you want it, and plug it in and get your electricity out. So some of the same attributes that let us do all those neat things actually help us reduce some of our technical and regulatory risks so that we can go to market a little faster. Go to the next slide. So we are uniquely positioned to enter the market more quickly than any of our competitors because we are what we like to call ourselves a venture-scale nuclear technology, because our development costs are 80 to 90% less than other nuclear technologies, and our capital costs are much lower. 40 million builds you a UPower module, while it might cost over $1 billion for other small reactors. From a customer perspective, we generate energy for up to 40% less than the competition. So our incomparable performance helps us build partnerships with customers who face a very real problem today that we can help solve, like oil and gas producers, miners, the military, remote communities, even humanitarian efforts. And that will help us build partnerships, sell reactors, and enter a $35 billion and growing industry, or market, I should say. We're seeking $8 million, $1 million to set up our phase 1 testing, and then $7 million to complete our phase 1 testing and gain customer commitments in the field so that we can put our first unit, demonstration unit, online within 5 years. Thank you.
Great job. So we're going to move right into the questions. So any order, who would like to jump in? Yes, Bilal, go ahead.
Sure. What is the typical size of the nuclear unit inside a submarine, the nuclear-powered submarine, and why can't we just containerize that and sell that?
So it's about 100 megawatts thermal. Okay, they use that for propulsion. So the conversion to electricity is a little less. It's on the order of 20%. They use a lot of steam for propulsion. Problem is it's not that small. It's pretty small, but our unit's a lot smaller. And it is containerized in the sense that you'd have to ship 3 or 4 units, or 3 or 4 trucks out to put it all together, not one truck. And it uses high-enriched uranium. We use low-enriched uranium, so it kind of gets away from that. So it's also much more expensive for them than us.
Question, Willem?
Yeah, so can you explain again why is walkaway safe, as you're creating the heat? And then if you can't dissipate that heat, why can it then still be built safe?
So can you go to the previous slide? So if you look at that diagram, you see there's cooling pathways that go up into the side. We're able to move heat upwards during operation, okay? Let's say that we walk away from this unit after it's operating at full power. What ends up happening is the system is going to shut itself down naturally. It just runs out of fuel, it just burns out, and it's done without any operator action. So then you just have to remove a low amount of heat. And what's great is if you can't move it vertically, you can move it out the sides.
So sorry, what's moving vertically?
The heat. So our primary cooling pathway goes up.
Right.
Okay, so if you can't move it that way, you can just move it out the sides. See those kind of orange bars coming out the sides? We use heat pipes that come out laterally that can move heat always. And the great thing about those is they're completely passive. They don't need pumps or valves, and they just turn on when you need them to turn on.
But if they get blocked on both sides, you still have the problem. Like an earthquake or a flooding or
so
whatever you get.
We're greatly designed for an earthquake or a tsunami. So worst case, you wipe out that top side. It's really hard for you, because that's in a bed of sand, basically. It's really hard to take away the ability to move heat out of those side pipes, even if it gets twisted around the unit. So it's always able to do it. See, we have a very low power density, so we're always able to move the heat out.
Next question, Gail.
So a few times you talked about your competitors, and you've got some data here, 40% cheaper energy, et cetera. Are you meaning compared to nuclear reactors, or are you meaning compared to other fuel cells or other remote power generation technologies?
Specifically to diesel generators in these areas. So
to diesel generators,
current,
but
yes.
okay. But there are a lot of other.
Yeah, and then oftentimes a lot of fuel cells come in at similar price point to what we pick for diesel, because that range can vary from cheaper than what we can produce in certain areas, all the way up to well over $1. But on average, we see it comes in 30 to 35 cents a kilowatt hour.
Go ahead, Nikhil.
You'd mentioned looking at utilizing thermoelectric generators for the thermal to electric conversion. What sort of conversion efficiency are you assuming? Are you thinking of proven technology there, or is there development required?
There is some technical risk, and I'll tell you, we're assuming 18%. Now companies, the technology we're basing it on is in the exact temperature range that we're operating, and they've shown 20% in the lab. So we go up from there. So there's hope in that field, in that area. Additionally, some other companies have recently come out with 20 to 22% efficiencies at lower temperature ranges than we would operate at. So it gives us some belief that we can get to that number, and it seems like 18% is kind of on the lower end of what seems to be achievable today. But there is some uncertainty about how it scales exactly to what we need, and that's one of the things that we aim to test and show.
So Nikhil, starting with you, last piece of feedback for the night, what would you like to send Jake away with? What kind of message?
Yeah, I guess it's the idea is it's interesting from a technology conceptualization phase, from a technology conceptualization point of view. What I'd say is, and you may have already done this, but go talk to a lot of prospective stakeholders, customers, suppliers, regulators, and get as much feedback as you can as to what they're going to throw at you, and incorporate that into your design process here.
Feedback, Gail? What should Jake wake up and do tomorrow morning?
go find some government money if you haven't already. Get some help on an SBIR and go get some grants, and because if you're going to need $8 million, you know, I'd get some non-dilutive funding right up front.
Takeaway advice, Willem.
Well, so yeah, I'm personally convinced that if you think about a low carbon future, there's a room for nuclear, and I think the environment sort of open up to relook at these things in a way. I think the way you describe it, you have to address safety a little bit. So I think going smaller on the one hand is good because it gives you an application that's sizable, but then you have to convince there is not enough radioactivity sort of exposure meltdown that requires you to go big on safety, and then you can't afford it. So I spend a lot of time sort of figuring out sort of right sizing it based on the balance of risk and what you need to put in place, because I think a container size, other than the military, probably won't get away with that. So you have to be very careful when you want to go. And I do agree that oil and gas for sort of in situ upgrading, that's a great application, especially if you're very heat focused. So there you don't even have to worry about generating electricity because you just pump the heat downhole, and that would be a great application for this.
Okay, and Bilal, the last piece of feedback for the last pitch of the night.
This is a good example where I couldn't tell what exactly the technology was, but clearly the general idea, I'm assuming there's a lot of technology in here, is a good one. If I was the entrepreneur waking up tomorrow, I'd take a flight out of the US and figure out which country I'm going to go to, because this is not going to happen in the US in the next 10 years, right? So I'm an entrepreneur. I want to make it happen in the next 10 years. You know, look, I've looked at several nuclear companies. You know, TerraPower is doing work in China and Japan, right? There's a reason for that. So I would have to figure out which countries, which applications, and just go do it there, and not even deal with the nuclear regulatory problems here, which are beyond rational, frankly.
Excellent feedback from all of our panelists. Round of applause. Great job, Jake.
Okay, so you guys should all pull out your phones now, or your laptops, and hopefully you have gotten an email from me. Anybody get an email from me in the last 30 minutes or so?
Raise your hand if you got the email.
Awesome.
Okay, you can vote.
So use that and go vote. And in the meantime, we're going to tell you about some announcements we have. So as Chris was mentioning earlier, Ultralight Startups runs events just like this in two different sort of industry sectors. One for energy, as we heard today, and also for sort of high-tech startups or internet startups or software startups. We call that series the Investor Feedback Forum. We have some events of that series coming up on Thursday, April 11th in New York City. If you happen to be in New York or know somebody that is, come and check that out. That's next Thursday. The next one of those in Boston is on Thursday, May 16th. So that should be more convenient for you. The next Future Energy event we have 20 days from now on April 24th at Stanford University in Palo Alto, California. So we'll see how these Stanford teams fare in relation to the MIT teams. And then the next Future Energy event after that, out here on the East Coast, is on Thursday, June 13th in New York City. We have an announcement from our partner, Brian Russett of Cleantech Open. So go ahead and talk about Cleantech Open.
Hi, Cleantech Open is the world's oldest and largest clean tech startup accelerator program. We focus on mentoring, training, networking, and visibility. Since 2006, we've worked with 727 companies who've raised more than $800 million in private capital. It's a 3-month program beginning in June, and applications are due May 1st. So if you have any questions or want to buy me a beer, I'll be at Meet All.
Fantastic. Thanks, Brian.
Thanks, Brian.
Cleantech Open's been a fantastic partner of Ultralight Startups for some time now, I guess since the very beginning. So definitely apply to Cleantech Open if you have a startup. The contest winners, Chris, you want to mention these?
Absolutely. So these are all the different partners that supported the contest. So if you're submitting your votes right now, this is what the pitchers are competing for. We have a free application from Cleantech Open Northeast to apply to one of their accelerators, an interview with the Surge Accelerator Program in Houston. Agira is supporting a prize. Greentown Labs is hosting a 1-month pass for the winner of tonight's pitch. Mintz Levin's providing legal services credit to the top winner. WorkBar provides a 2-day pass to the top 3 winners. So that's a great opportunity to check out co-working space. Amazon Web Services is sponsoring $500 credit to the top 3 winners of tonight's competition. And Action, the New England network of incubators, is providing a pass to their program. So all great prizes, all great resources to helping the entrepreneurs tonight take their companies and grow them.
Is anybody still voting?
Still voting.
Okay, get your votes in shortly. And in the meantime, we can consider how to find Mead Hall, which is where we'll all be going for drinks after this.
And speaking of, we have the upstairs of Mead Hall reserved. So it's a private area. When you go in, go straight upstairs so we can continue the networking. As soon as the voting is finished, as soon as the winners are announced, feel free to go straight over there. Try not to linger around here too much because you'll never make it over to Mead Hall. Go for it.
Mead Hall is a very special place, not only because it's a great bar, but it's a very special place because before it was a bar, it was a bookstore called Quantum Books. And those of us who studied at MIT have spent a lot of time at that bookstore. Unfortunately, that store went away, but now it is the hangout place for not only generally for MIT students, but I want to point out the MIT Energy Club organizes every month a get-together between students, academics, professionals, investors, the kind of guys who are looking for the next CEO gig to hang out and get to know each other. So, maybe on the MIT Energy Club website, you'll be able to figure that out. But every month, I mean, I know I'm there, but I know a lot of other VCs and others are there too if you want to come and, pitch your idea to an investor.
Awesome.
Thanks, Bilal.
Thanks, Bilal. Okay, so we have some results.
Drum roll.
I'm going to refresh this one more time. So the winner is, wow, by a landslide, Jacob DeWitte of UPower. Wow. Second place. Come on up, Jason, or Jacob. Come on back up. Looks like second place is Open Water Power, is that right?
That's right, yeah.
And then Matt, by one vote. And then third place is Agira, Bal Mukund Dhar. Is that right?
So come on up, Rory and Bal.
Well done.
Good job.
Well done. Okay, and now for the really big prize. Eternal gratitude. So eternity is a very long time. Who was the best panelist today? Bilal Zuberi of General Catalyst. Well done. Congratulations.
Congratulations, Bilal.
The MIT Clean Energy Prize wants to award a prize. Here's Molly, I believe, with a giant check.
So we're so happy that one of our teams won. It was great to hear from all of the other 4 teams here. I'm Molly. I am the third in the triumvirate of managers of the Clean Energy Prize this year. Hope to see us some of our other events. And I'm very proud to present this giant check to UPower.
Fit that in your wallet.
Fantastic. Okay, so congratulations to Bilal, Willem, Gail, and Nikhil, and we will see you all over at Mead Hall momentarily.
Thank you very much. Have a good night, folks. See you soon. Great job.